Hello everyone, Aaron here and welcome back to Leetcode. Today we're doing the delete columns to make sorted problem. You are given an array of n strings strs, all of the same length. The strings can be arranged such there is one on each line making a grid. So if we have ABC, BCE, CAE, we can see that these three form a 3x3 grid. We want to delete the columns that are not sorted lexicographically. So lexicographically is just a big long word that means effectively in alphabetical order. In the above examples, the column ABC is fine and CEE is fine, but BCA is not fine. B and C is, but A is in the wrong place. Return the number of columns that you will delete. So we would strike out this column here, so that would be 1. CBA, DAF, GHI, so this is the grid. CDG is fine. BH is not fine. AFI is fine, so we would delete 1 column. AB, this grid is all good. This one here, ZWT is bad, YVS is bad, XUR is bad, so 3 columns get deleted. So this problem is basically a transposition problem. We have the strings arranged like this, but we would rather them be arranged ABC, BCA, CEE. Basically, we want to turn the rows into columns and the columns into rows. And it turns out Python has a very, very nice way of doing that. So we can say the cols is the zip of the strs. Let's call that let's turn it into a list just for printing purposes. And see what cols looks like. Loading. Oh, they're doing proper type checking now. That's interesting. Anyway, so here we can see for this first one, we get CDG, BAH, AFI. So now we have these columns which are what we want to check. So what we can do is we can say, well, hang on, which of these columns is sorted? Now I no longer need this zip up here. So now I need to define is sorted. What we can do is we can think, well, what does it mean for a list of letters to be sorted? Well, all it means is that at position I+1, it's greater than the value of position I. C goes to D, D goes to G, so on and so forth. So for I in range len items -1, if items I is greater than items I+1, return false. We have found some items that are out of order. If we make it to the end without having found anything out of order, we can return true. So in the example they gave us here, CEE, this is fine because E is not greater than E, it's equal to E. So let's now check. This seems to be doing the right thing. So we found true, false, true. So true, 0 and 2, these two here, are both sorted, but column 1 is not, so we need to delete 1. What I'm going to do next is going to seem a bit weird. Oops. And what that is I'm going to return the sum. Oops. Still getting my head back into these key combos. Is return the sum of that list we just looked at. Now that's a bit of an odd thing to do because this is true, false, true. Ooh, that's not what I want to do at all, is it? Anyway, doesn't matter. So I want to count the things that are false. A true counts as a 1 and a false counts as a 0. So if I flip those around and say the trues are falses and the falses are trues, that's what this not is doing. That basically lets me count how many false things there are. Unmatched parentheses. Oops, I've got a bonus bracket there. Excellent. We're able to correctly identify and then count how many of the columns, which columns and how many of the columns need to be deleted to make sure each column is sorted. So this problem is actually quite nice. Basically, the entire puzzle comes down to this line here. Can I effectively just transpose the matrix, the grid? And then it's just a simple check for sortedness. We could do this differently with some nested for loops for indexing, but here this kind of just takes care of it all. This comprehension here is nice and tidy. This sum is nice and tidy. It's just this one for loop we've ended up with explicitly here, and it's straightforward as well. This is sorted check is a very standard kind of check you'll be coding up. It's an early return check. So let's submit it, see if there's any edge cases I have not thought of. Doesn't look like there are. We've made it. We're pretty standard on pretty much everything. We're not super fast. We're not super slow either. That if you did the indexing trick rather than the transposition trick, you'd probably be a little bit quicker, just because this has to reallocate memory, whereas the indexing does not. Anyway, I think that's enough rambling about this solution. Do remember to like, comment, subscribe, all of that good stuff. I almost forgot my own outro. I am still getting back into this after a holiday. Anyway, I will see you next time. Bye.